This is example 8 from lesson R.4. We are simplifying by rationalizing the denominator. Now, to rationalize the denominator, the object is to eliminate any radicals that appear in the denominator of a fraction. The numerator we don't care about, but in the denominator they need to go. And they also need to be simplified of any perfect squares that they might have. Okay, so in part A, all we really want to do is we're going to multiply this fraction by 1, by a fraction that's equivalent to 1. And as long as there's only one radical in the denominator, this one's pretty quick. So I'm just going to take the square root of 5 divided by the square root of 7, and I'm going to multiply by the square root of 7 on the top and on the bottom, because I know the square root of 7 times the square root of 7 is the square root of 49, and I know the square root of 49, that's 7, and the radical is gone from the denominator. Now we just have to simplify the numerator. The square root of 5 times the square root of 7, that's the square root of 35. 35 will not break down into any perfect squares, and so that means my final answer here is going to be the square root of 35 over 7. When we get to B, we're going to do the same thing in that we're going to be multiplying by a fraction equivalent to 1, but this one actually has two parts to it. It has two terms in it, square root of 13 minus 10. And so we're going to be a little bit clever here, and we're going to use what we know about the difference of two squares and the fact that when you FOIL them, the middle terms drop out. And so when I'm multiplying by 1, I'm actually going to multiply by the square root of 13 plus the square root of 10 here. So this is going to multiply into a difference of two squares. And I can see that this is one of my special products, and that my middle terms are going to drop out because I have the same term in the front and in the back, but one's positive and one's a negative there. And since we want that fraction to be equivalent to 1, be sure you're multiplying by the square root of 13 plus the square root of 10 on the top as well. Okay, this is going to give me, on the top, I'm going to have 12 times the square root of 13 plus the square root of 10. In the denominator, okay, we're going to take the square root of 13 times the square root of 13, that's the square root of 169. Then I'm going to multiply the square root of 13 times the square root of 10. That's going to give me the square root of 130. Now I'm going to multiply negative square root of 10 times the square root of 13. That's going to give me negative square root of 130. And then the square root of 10 times the square root of 10, which is going to give me a negative square root 100. Okay. Adding like terms shows me that my middle terms here are going to drop out. The square root of 169, I know, that's just 13. The square root of 100, I know, that's just 10. So I actually have 13 minus 10 on the bottom, and I notice that the radicals are gone. That's good. On the top, I'm not going to multiply that just yet because I think I'm going to be able to cancel some stuff. So let's see. We've got 12 times the square root of 13 minus the square root of 10, and on the bottom, 13 minus 10, I know that to be 3, and I can cancel. 3 can actually go into 12 4 times. And so we're left with 4 times the square root of 13 minus the square root of 10, or 4 square roots of 13 minus 4 square roots of 10. And that's the end. Hang on. Did y'all notice how I magically manifested this plus sign into a minus sign here? That shouldn't happen. That should still be a positive. It's square root of 13 plus the square root of 10. This one should be the square root of 13 plus the square root of 10. And then this one should also be the square root of 13 plus the square root of 10, which would make this one the square root of 13 plus the square root of 10. So I apologize for that. As I said, I magically turned this plus sign right here into a minus sign in this step. I didn't mean to. These should all have been positive signs up here in the numerator of the fraction, because originally multiplied by a positive sign down here in the denominator and also up here in the numerator.